Hi, this week we're going to talk about modules, namespaces, classes, and this is kind of the the week we're going to actually spend quite a bit of time on OOP, object-oriented programming. And so far, our programs have been pretty simple, and we have mostly a main function and just a couple of lines of code. Now, in reality, when you have a project, you're going to have thousands or even tens of thousands of lines of code, and how do you organize them, the code in your program? You have a large program. You need to break it down to sort of, smaller logical units, so that makes it easier to manage, and everybody can, if you have a team, multiple people could potentially parallelize and working on different parts of the program. And historically, there we use headers to organize functionalities and modules. Uh, as you see, we normally even call headers as modules because that's the intention of uh, designing your program. We divide things into different headers, and the header mechanism has been deprecated in this since we have the modules in C++20, and that's the newer way of organizing your code. Now we also have namespaces that has been in the standard for a while. And of course, that's been very popular. You see the standard library, everything is put under almost everything, yeah, under the STD namespace. That's the standard namespace. So what are the differences between headers and the modules? So the headers, as you have noticed, many of the programs you write, you at least do a hash include IO stream. And that hash include is a pre-processing directive. And that is usually processed by this part of the program that's called the preprocessor. And recall that the compilation and linking process of a C++ program. So part of that is a pre-processing. So if you have the include directives and also like macros, those things they are a carryover feature from C, and they haven't been changed for a long time. And of course, C++ has come up with many different ways to deprecate those features. The only thing that has not been able to deprecate is that include until we have the modules now. So that modules feature has been in the working for a long time. So pre-processing really, it comes down to just a simple textual replacement. And the preprocessor does not attempt to understand, try to compile the code. That's the job of the compiler. So when the compiler starts processing what's called the translation unit, which is, you have a source file. After you process those include directives or macros, the things that need to be replaced, they are replaced. And then the compiler will process that code. And the compiler basically will now see those pre-processing directives. And because of that process of textual replacement, there's one nagging issue is this violation of one definition rule. That one definition rule, you may see this in different forums. People talk about ODR, that's what it is. I call it one definition rule. Means if you have a entity, maybe it's a variable, a function, or maybe a class, you can only have a single definition. So that's why many of the headers typically you see this include guard. We'll call it guard because we don't, if if the headers are include, A includes B and and C includes A, and just kind of there's a lot of includes going on, and you want to prevent the definition gets sort of included multiple times. That's why you have this include guard that by using sort of is a little clever play on this directive, the if, the hash if, and then you define a symbol, and then once you have included once, and that symbol has been defined, and so it will not be included again. And so that those kind of things are in there, and again adds complexity. It's not very intuitive, and that's not the only thing that can cause one definition rule violations. There's just many gotchas, and in that whole sort of a pre-processing compilation process, the entities that you define in the headers typically have two kinds of linkages. You got internal linkage, external linkage. Linkage is talking about how does the linker figure out uh, which parts of the program, are going to be linked to make your executable. And how does it define the definition of a one symbol? If it's like where does it go search for them? So it depends on how you define your symbols. For example, the non-inline, we don't really haven't talked about much about inline, so that but anyway, so you know what const is, and so if a variable is a const qualified, like for example const double blah, if that variable is defined in a global or namespace scope, we're going to talk about namespace, and of course you're already familiar with the namespace, but we'll come to namespace in a bit. If it's in um, the global namespace, which basically means there's no namespace, it's just a global in the global scope. In that case, those variables are going to be having internal linkage, means they can only be used in this single translation unit, in its own translation unit. And that is the internal linkage. And so internal linkage is okay. It's good because then you're kind of those things, symbols can only be used within your own translation unit. It will not pollute sort of the the program or the parts of the program that import your header or include your header. Then there's also the external linkages. External linkage, the most of the symbols that you define, like functions, elums, classes, templates, non-constant variables, if they're in the global space in the header, and they would have the external linkage, means that they are accessible from other translation units. They are basically quote unquote exported by default. And that's sort of the kind of the cause of many of the issues that if you're not careful. Now let's take a look at the contrast that with the modules. Module introduced a different linkage. It's called a module linkage. And when you define a module, the entities you define within a module, they have this module linkage. It's basically they're accessible within the module, but they're not accessible outside. It doesn't matter. Really, it doesn't matter if it's a const qualified variables or non-const qualified variables or functions or classes or whatever. As long as you don't export them, basically by default, they are not exported. By default, they are local entities. So you don't really worry about name clashes or polluting the program, the parts of the program that actually import your modules. So basically, module is a self-isolating unit of functionality, and for the most part, it will avoid the ODR violations. Pretty much, you don't have to worry about them anymore. And also, another key feature of a module, why is it so good, is that it's going to reduce the compilation times. And the modules can be compiled just once, and then it will not be like the headers where when you include a header, you're actually including all the source code from, let's say, library, standard library, IO stream. You're including all the source code from an IO stream file into your program, and that whole thing gets compiled, right? So that's kind of slow, right? Because the standard library, those headers are huge. But then with the modules, those modules are compiled. Well, unless you change the interface, it will not need to be compiled anymore. So that's when you're using that, you're saving all this compilation time. You're only compiling the parts of the program that are changing. So that's great. Um, okay, so how do we define modules? How do we use modules? So those are the things what I call primitives. So first of all, declare. How do you declare a module? Declaring a module is simple. You just export module. Those are keywords, and they give a module name with a semicolon. Is like a statement. And then how do you export an entity? So let's say you define your declare a module. You got a file, you declare the module, and then you're gonna go ahead and define your entities and your variables, functions, classes, whatever. So those entities, if you want to export any one of them, by default they're not exported. Remember, there's a module local entities that by default they are just remain local. They will not be exported unless you want to. So to export them, essentially you just add this export keyword in front of it. You can export, sort of entity by entity, or you can export a whole bunch of them within a block. Right? You can just basically use this export with a block, curly braces, and put a bunch of things inside. They're all going to be exported. And you can also export imports. So import. So let's say you want to use another module. Essentially, just use import. You import a module. But if you want to re-export what you just imported, by the way, if you import something, that whatever you import is not going to be exported by default. Like you can use within your module, but not really exported by default. But then it's not the same thing with the headers. Within your header, if you include another header, and that whole thing is included as part of your header, like they are whatever is supposed to be exported, they're exported. Remember that external linkage. So that is kind of a problem with the header. Now with module, it's very safe. You import whatever you want. You can use within your module, but it will not be exported by default unless you do want to export them for some reason, which is a rare situation. So here we can export and import. And then you can split your module code into interface files and implementation files, right? Just much like your header versus your source file. So they can be separated out. And now, as we said, let's say in your module definition, well, let's actually take a look at a simple example first. And let's take a look at 1101. 1101 is we have a simple math module. So see, this is how you declare a module here. Export module, math, that's my name. The name that I give to this module. And then export, this is actually, see, this is of course, this is abbreviated function template. It's a square template, squaring a number. And I got a bunch of other things. Export, another thing is a constant. By the way, in the book, it's actually a constant double. But then because there's this, in this case, when I'm opening this up in the GCC, this is for the Mac users. And it doesn't really support the GCC 11, the sort of the development branch. It doesn't support that, so that's why I'm seeing here sort of a little function that's returning it's a constant expression, but I don't want to get into that a little bit. But this is essentially as efficient as a constant. But then we also have other things like enum. This is actually scope the enumeration, right? So you see this enum class, and that can be exported too. And that's another entity we're exporting. This is odd function. We don't have the export in front of it. And that means this function is module local. So it's got a module linkage. It will not be exported. You can use this function within your own module, but the outside, whoever is importing your module, they're not going to see this symbol. And this is another function that we're exporting, okay? And so then let's say we have a program here. We're going to use our own module. So then you import this math module that you just defined. And now we can use the things that are defined in that module. Remember that, you got this square function, you got the lambda function, you got this get oddity function. Those are exported. Okay. And here there's a comment that says basically if you're going to uncomment this out, let's say you're going to import use this is odd function, that is an error because remember this, you can use this within the module itself, maybe within the module interface file or implementation file. But here we're importing this module, this is not visible. So you can't use it. Okay. All right. So here's the thing about, so here's another issue. If my module interface have, let's say we have export a function that uses the string parameter. And of course, within my module implementation, I would have to import the string module, right? But then that will not be exported. Let's say I don't want to export the whole string because you're using my module. I don't want to have to bring that string into your scope to somehow pollute your importing space. So when you import this module, you can still use that. You can use that function that actually takes a string parameter, right? You can use that unless you're making a string object, of course. Then you have to import string in your program. But otherwise, let's say you just use a C-style string, a constant, right? You try to pass this into this function, and that will work because that is allowed because the kind of is a reasonable compromise. So essentially, the imports within a module do not propagate. So like okay, here it doesn't show. They actually show another example here instead. Let's say I'm going to explain this a little bit more. So within a module, actually, that's yeah. You import string because you're exporting a function. So you're exporting a function that uses string as part of this function declaration, the function prototype, essentially. And this is not exported, as I said. You can export your import, but normally you don't want to do that. So that's what I'm saying here. Imports do not propagate. However, the declaration, they are reachable. They can be propagated transitively. Basically, what that means is if you import this module and then you want to use this function that which is exported, you don't have to bring string into your scope. You don't have to import string in order to use the function, unless you're using that type in your program, and then you, of course, then you have to import that yourself. And maybe use auto if you want to avoid even using that type to bring string into your program. Then you can just, this is a function returns a string. You can actually assign this to a variable with an auto type, and then you can avoid that thing as well. Okay. And then the declared names are not visible. Basically, this means that this string, of course, is not visible. Okay, you can use this exported function without having to bring string into your scope. There's another thing you can do with the modules. If you got a lot of code in your module, let's say your standard library, they're pretty big, and then you may want to partition your module into different parts. And you can partition your interface file as well as the implementation file. So how do you partition a implementation file? So you got a module implementation file. How do you partition? So here's a here's an example here. And when you see a module declaration here with a name, but without export, okay, because you do not see export. If you do see export, that's an interface file. If you don't see export here, and you're still using this module declaration here, that's an implementation file. This is intended to implement some of the entities, maybe as a function in this file. So you're separating the interface from the implementation, okay? So this is the format. Implementation partition, you have to declare your partition. So the name of the module is called a Roman, and then this partition is called the internals. Now, this is only partitioning the implementation, not the interface. There's a bit of difference there. So when you have an implementation partition, this is sometimes called the internal partition because this is not exported. It will only be used internally within your module, interface or implementation files. And then you can actually import another partition. So while you're implementing, because now let's say you got a bunch of partitions. Of course, you may have some partitions that are kind of common code. Then you may want to use the other partitions. Of course, you can. So how do you do that? Essentially, you can just let's see. We have an example right here. So here we have another implementation, a module implementation file, right? When you see this is a module with a name, but without export, this is an implementation file. So in here, we need to use another partition to implement because now see this colon, now you don't need to prefix this with the module name. Context is clear, right? We're in module Roman. So we're importing this partition, whatever that we have defined there. This is, remember, this was a partition, implementation partition. So we can use the whatever code that you have there, you can actually use it right here. All right. And then we can also partition interfaces. So the format here is, again, you have this export keyword here, and then the partition name you follows this colon here. This is how you make a name that's a partition of a module. So, for example, this is the interface partition. We have, this Roman module. We have this part of this is a partition called a from. And in here, we have a declaration of a function we're exporting, which is the from Roman function we're exporting here. And this is the interface partition, right? Because you see this export keyword here, that's what makes the interface. And then you see this colon with a name here, that's the partition name. So that's really very simple to recognize. And once you have a bunch of partitions, you need to actually bring them together by using a primary interface file. This is a primary interface file. This is where you're declaring this module interface, Roman, okay? And then in here, we're exporting the import of the partitions. So all the partitions are going to be re-exported. I mean, that kind of makes sense. We want, these are the parts of the whole, right? We want to export the whole thing. So this is typically what you can do. But we cannot export that internals partition, remember, because that is the implementation partition. It's not meant to be exported. Okay. And then there's a global module fragment. So why do we use that? Because a lot of the legacy code, obviously, they're still using headers. And sometimes we don't have a module for a certain header. So in that case, you can put that include, all the includes that you need in your module, put that in the global module fragment. Basically, outside of that module declaration here, this is here, this is a marking, this is called this. So you have something before your module name or export module name. Remember the difference between them is interface versus implementation. And then right before this, you can include headers if you need to, because you got some backwards compatibility issues here. And then this line, the declaration, that's what's also called the start of a module purview. Everything starts from here. That's the regular module interface or implementation code. And so before this, you can put some headers in there. And at the very top, typically you should also have a module semicolon. That's kind of just a marker to help the compiler to recognize whether this is a module file or not. Um, so this is basically here is the start of the global module fragment. So when it's outside, these things are outside of the module purview. That's what they are basically in the global module. This is what called a global module. Anything that's outside of a module, not within the module, they are in this so-called global module. Okay. Similar to the namespace thing, if you have stuff that's not within a namespace, that's in so-called global namespace. And we're going to come back to that in a second. So in your module interface or implementation, typically you got some bunch of module imports that you're going to use those functionality, those modules to implement your code. You may also include some special headers in your interface, module interface, that could be for configuration for export purposes. Um, so anyway, then you may got a bunch of module interface code in here, entities that you want to export or things that you do not want to export. So you got maybe other things like even templates. Now, remember though, the template, if you have a function template, for example, you got to put the whole template definition in your interface. That's because the compiler needs the whole template definition in order to generate or instantiate functions for at the place of invocation. Now, back to this, the Roman example. Actually, let's run this thing actually. So this now what I'm showing here is for the Mac users, and I'm gonna show for the Windows users in a second. So this is the same instructions I had before. If you so first you have to enter this GCC modules folder. So remember, so here this is the root of your project, right? So then first you go into these modules, GCC modules. This is for your GCC 11 to work on. So once in here, now if you have not run if you have not run the header unit script, and you need to run that first, that will generate some of the header units for standard libraries so you can import. But then I have run this, so I don't need to run this again. So, and then let's say I want to build the example, the chapter 11 / X1105. Okay, I want to build this program. So I just essentially I point this to the path. So now you see this is actually it not only builds it, it also runs it. And the executable is just called a.out, which is the default executable name from a GCC compile. And so this is just simply runs that program, which is a simple program, obviously. So that's the main function is in here. So essentially there's only 2 lines. It calls those functions. Okay. So this module demonstration basically only does the translation between Roman numerals and Arabic numerals. Okay. So and as we kind of already went through this thing, this is a main module that's partitioned into 2 partitions. Okay, and then each partition will have its own interface file. All right, and then there's also an implementation partition that's used within the implementation of one of the partition interface, the from partition. So that uses the other implementation partition, which has some common functions there. It kind of just demonstrates the variations of different things you can do with the modules. And then here you got this program where you are importing this Roman and then using this. You notice this squiggles, error squiggles, because this is, the IDE doesn't have a great support of this module feature just yet. So this will come because the compiler support of this module is still not quite there yet. So that's why the IDEs are not catching up. Of course, they kind of are waiting on the compilers. So, but you know, we can make this work by using GCC 11. That works. Okay. Now let me go to share the Windows side. Well, yeah, let's do that. All right. So the Windows side, like now, there's one program I have to use the MS build. Basically, you're familiar with the Visual Studio solution file. That's the MS build tool. For the Roman example, I actually use the MS build. But then the simple examples like the 1101. 1101 has a simple math module that I show you on the Mac side, and this is on Windows side. So what you do is, again, it's the same thing. Like the same you run every other program, just you just use the B command to build it. As you notice that on the MSVC side, it supports exporting the, constant from a module. So that's why you see this here, this was in the book. However, it does not support abbreviated function template. That's why you see this whole template written now, like in this format. And then let's, run this program. Okay, so that's what the program does. Let's enter odd number. This is what it does. Very simple. Okay. Now for the 1105, so you just click on this, double click on this solution file under the 1105, right? And then you are in this debug x86 sort of a configuration here, and then you run that configuration. Okay, so that already finished. You see this runs that program, right? The Roman numeral translations. And then you just press any key, except the return key. Just press any key, then you will close that. So you'll see the Visual Studio has a very good support of the modules. I mean, kind of is still, in terms of IDE, Visual Studio is ahead of the game. So they kind of, this is why, but then if you try to use the build tool for this example, that support is kind of lacking a little bit. It supports simple situations, scenarios, but in this Roman example, I used basically all the primary features of the modules. That's why certain tools are not, they are not quite there yet. So that's kind of the compromise here, as you see. All right. Okay, so let's go back to slides. Now, namespaces. So of course we have seen namespaces, and we use namespaces a lot. From even the very simplest program, we may use the namespace because that's a standard namespace, std : So, so we're not gonna spend too much time here, but so first of all, the global namespace, that basically when you have no namespace, your symbols are defined just without any namespace, then that's the global namespace. And we kind of talk about this. If you have a local variable, local name, or something that kind of hides the one that's defined globally, and then you can still access the global one with this scope resolution operator without a name, because there's no namespace here. Okay, so this is a kind of example there. And defining a namespace is simple. You simply use the keyword namespace and give a name, and then include everything in the namespace in that pair of braces. namespace can be nested. So of course you can have namespace inside namespace. That's not a problem. And you can also have the namespace definition, whatever you put in namespace, separated in pieces. It means that you can add to a namespace in many different files. For example, you can even add stuff to the standard namespace that you want. In fact, that's exactly what we did with the format library. Remember this, the compilers does not support the format library yet, the std::: format. And so we have added something that actually will fill that gap. And so that's the reason we can do that, because your namespace can be separated into pieces. And the namespace is an orthogonal feature to modules. Now you see, okay, namespace is another way to organize your code, right? Yes, but modules also, right? But of course, you now understand, differences. And so even though probably you want to use both, you use modules and namespaces, but then, well, of course, it may be a good idea to align the names. So, so if you have a math module, maybe you define a math namespace inside and they export those symbols within the math namespace as an example. And we're going to see a simple example right away. Let's take a look at an example first. And for that example, we go to Windows side because that is yeah, okay, over here. So 1107. So we have this math module here, and calculates a bunch of averages and means, okay? And so we have put those things inside namespace. In fact, nested namespace, even 2 levels. We got a one function here, function template, square, in math, and we also got a bunch of things under the average. We're grouping them together, called that averages namespace, and they're nested within math. And so this math, then we got the module implementation here. This is here, you do not see the export keyword here. So that's the implementation file. And this also demonstrates here that because we have to include the CMath, we're using CMath function, the C style math functions, we have to use an include here. So because we use include, and so this is a kind of in this global module fragment, okay? So then we're defining those functions here. We're implementing, this is the implementation file. And then you use that, you import this math module. And here we use this using namespace directive. So that will bring the symbols into this local function scope. And so that we don't have to prefix all these function calls with math : averages : You can do that, of course. So that is that you're familiar how to use that, okay? And to run this is again, so I said only the 1105 is using this MS build with the solution. You run that within Visual Studio, and then 1107 is a regular build 2 build, so you can use a build 2 to run, run this as well, okay? Like the 1101. All right, so back to the summary. So to summarize, the modules allow you to organize your source code into logical, self-contained building blocks. That's really what they're designed for. And only exported declarations are visible within files that import that module, okay? Exported declarations, so everything is not exported, they are module local. Only changes in the module interface require recompiling consumers of the module. This is one of the key advantages of a module, is the compilation time is going to be much reduced compared to headers. Module code can be separated into interface files and implementation files, of course. And this is just a review of the syntax, and it's fairly simple. You look into the code, and you're going to remember that in no time. There's only 2 keywords here. So partitions cannot be imported outside of the module. Yes, there are internal code organization technique, but they are not really external thing. Partitions can import other partitions, of course. You use this import with a colon, the partition name, because is in the module context. Partitions must be re-exported from the primary interface, like the Roman example. And this is basically talking about the interface partitions, by the way. Implementation partitions, you do not export them, only the interface partitions. The module declaration may be preceded by a global module fragment because sometimes we need to do an include. For example, that CMath header, we need to include it because there's no module for that. Namespaces are hierarchical grouping of entity names for avoiding name clashes. Really, this is more about just naming clash issue. That's kind of and then just logical grouping of your code. And then, of course, we have used the using directives and declarations quite a bit throughout our course so far. So this is just to mention that those things can be, you can use them, but typically it's a good idea to use them locally. Don't put that using directive globally, like outside of namespace, outside of anything. So that is what I have to share about this chapter. Okay.